Alright, hey everyone. So hope you're doing well today. Today we're going to talk about complex zeros. We're going to start off with talking about complex zeros of quadratic equations, and then eventually we'll get to complex zeros of polynomials. So what you do now is to solve this equation, x squared plus 16 equals 0. And then for part B, I want you to write x squared plus 16 as a product of two factors. So that'll be like x minus the first zero that you get from part A times x minus the second zero that you get from part A. All right, I'll give you another 30 seconds to finish this problem, and then we will discuss. Okay, so again, if you just came in, we're talking about complex zeros. So in the past, like 10 or so lessons of this unit, we talked about real zeros of polynomials. Today we'll extend our thinking to talk about complex zeros. Okay, so zeros that involve the imaginary number I. Okay, all right, so let me scroll up for the solution. And I see a couple people typed in the chat. Yeah, the answer is plus minus 4i. Right, very nice, very nice. Okay, so yeah, just if you didn't get that, here's the solution. You just subtract 16 from both sides, you get x squared equals negative 16. Then you take the square root of both sides, and as we know, it'll be plus minus because, so whenever you're taking the square root of both sides of an equation, you have to have plus minus because if you do it in reverse, right, if you square either positive square root of negative 16, then you get negative 16. And if you square negative square root of negative 16, you also get negative 16. Okay, but that's true for anytime you take the square root of both sides of an equation. All right, next step is you're going to factor out I. All right, so I is equal to square root of negative 1, as we know. And then we'll be left with I times square root of 16. Square root of 16 is 4, so we get plus minus 4i as our zeros. For part B, we're going to write this as two factors, so it'll be x minus the first one. I wrote negative 4i first, and then the other one is x minus the other 0, which is positive 4i. So if you distribute the subtraction, you're going to get x plus 4i, and then x minus 4i. And as a reminder, these factors are called complex conjugates, right? So remember from last week, right, we talked about like conjugates. So it's like x plus 4i, the conjugate of that, you just change the sign. So it's x minus 4i. Right. But yeah, I'll give you some time to copy this, and then we'll move on to the rest of the lesson. Okay, does anyone still need to copy this solution here? Please type in the chat or speak up if you do. Okay, if not, then I'll move on. So just an overview of the rest of the lesson. So we're going to just go through another example using the quadratic formula, and we're going to use the quadratic formula a lot in this lesson. So telling like I guess you could factor x squared plus 16 if you if you just knew like it's x plus 4i times x minus 4i. So technically you could do that, but if you have something like this where it's not a perfect square trinomial, right? It's not like x plus something times x minus something. And you have something like this, x squared plus 4x plus 5, you are going to use the quadratic formula. Okay, so yeah, we're going to do that. And then after that, it's just some practice questions. So 4 practice questions for the classwork. Okay, and then we'll be done. All right, so pretty quick lesson today. But yeah, let me get to the example here. So here we're going to have x squared plus 4x plus 5 equals 0. And then as we did in the do now, we have we're going to factor the equation into linear factors. So again, we're going to use the quadratic formula, which is negative b plus minus square root of b squared minus 4ac divided by 2a. And in this case, negative b is going to be negative 4 plus minus square root of b squared, which is going to be, oh, this should be positive 4. Yeah, so 4 squared as b. And then minus 4 times a in this case is 1, times c is 5. Yeah, so you get 16 minus 20 under the radical. So that'll be negative 4, right, under the radical. And then square root of negative 4, we can write that as 2i, right, because you factor out the I to get rid of the negative sign. And then square root of 4 is 2. Okay, so that's where we get 2i here. And then for the denominator, it's just 2 times a. In this case, a is 1. Okay, the quadratic coefficient is just 1 for 1x squared. All right, and then from there, we have negative 4 plus minus 2i divided by 2. And after that, you just divide both numbers by 2. You're going to get negative 2 plus minus I. Okay, all right, that's part A. For part B, we're going to factor this equation into linear factors. So just as we did with the do now, we write x minus the first 0, which I designated as negative 2 plus I. And then the other 0 is x minus parentheses negative 2 minus I. And then from there, you distribute the subtraction sign. You get x plus 2 minus I, and then x plus 2 plus I. So that'll be your answer for part B. Ready? All right, I'll give you some time to copy this, and then from there, we'll move on to the classwork. Okay. All right, anyone still need to copy this? Please type in the chat or speak up. Okay, now then I'll move on. So next is just the classwork. So there's 4 problems. You're going to do the same thing we did before, right? So these are the 4 questions. For this first one, it's similar to the do now, right? Subtract 9 from both sides, take the square root. And then for 2, 3, and 4, I recommend that you use the quadratic formula. Okay, so I'll give you some time to work on that on your own. Let's say we have 14 minutes left, so let's do 7 minutes. So 1:43, we'll come back and discuss the solutions. Okay, all right, I think that should be enough time. Let me scroll up to these solutions. All right, here is the first one. All right, the answers ended up being plus minus 3i for part A, x plus 3i, and x minus 3i for part B. All right, any volunteers to explain this first one? It's a few steps here. All right, we'll go to Miriam.
Um, so first I solved for x. So I subtracted 9 from the left-hand side. So you get x squared equals -9. And then I took the square root of -9. And so that comes out to plus or minus 3i. And then I rewrote that into like linear factors. So it was x plus 3i times x minus 3i.
All right, very nice. Thank you for that. So I'll give you some time to copy this, and then we'll move on to question 2. Okay, anyone still need this? All right, I'm going to move on then. All right, question 2, here we have x squared minus 4x plus 6.25 equals 0. So one thing you can actually do here is you can multiply, since there's a 0.25 here, this is 6 and 1/4, right? So to get rid of the fraction, you can multiply the equation by 4. But yeah, you could also just work with the decimal, 6.25. If you do that, you're going to get 2 plus minus 1.5i for part A, and then these are the factors. All right, any volunteers for this one? All right, we'll go to Pyramid.
Yeah, I just used the quadratic equation for this one and plugged in -4 for the first negative b, and then plus or minus radical 4 squared minus 4 times 1 times 6.25, and that's all divided by 2 times 1. And once you solve that out, I just left it in fractions, so I just got 4 plus or minus 3i over 2, and that's just 2 plus or minus 3 over 2i. And then you plug it into the um, to x minus 2 minus 3 over 2i times x minus 2 plus 3 over 2i. And you get x minus 2 plus 3 over 2i times x minus 2 minus 3 over 2i.
All right, thank you for that. Yeah, I think I had a different order here, but yeah, it doesn't matter. Just these are the factors: x minus 2 minus 1.5i, or as Pyramid said, 3 over 2. And then the other factor is x minus 2 plus 1.5i. All right, I'll give you some time to copy that. And then question 3. All right, anyone still need this one? All right, I'll move on to question 3 then. So this one was 4x squared minus 24x plus 37 equals 0. And we have these are the zeros, and these are our two factors. All right, volunteers for question 3. All right, we'll go to Max.
You mean just to explain it, right? Like what we did?
Yeah, just to explain what's happening here.
So this is solving for x. So we're going to use the quadratic formula. So we plug in all the values we have. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're just solving that, and we end up getting 3 plus or minus 0.5i as our factors. And then we're going to put that into the factor form, which is just x minus, you could do either x minus 3 plus 0.5i times x minus 3 minus 0.5i, or you could do it like where you distribute the signs in the parentheses, so you don't have two pairs of parentheses.
All right, very nice. Thank you for that. Yeah, so final answer is going to be 3 plus minus 0.5i, and then factors are x minus 3 minus 0.5i and x minus 3 plus 0.5i. Yeah, and technically you can leave it like this also if you want. They're both correct. Okay. I guess we'll go on to question 4 then. Here we have 2x squared plus 5x plus 10 equals 0. And for this one, yeah, we have negative b plus minus square root of b squared minus 4ac. So that's negative 5 plus minus square root of 5 squared, which is 25, minus 4 times a times c. So it's 4 times 2 times 10, which is 8 times 10, which is 80, right? All divided by 2 times 2, right, 2a. So under the radical, we get 25 minus 80, which is negative 55. So we have this, and then to factor out the negative 1, we have an I there. So it'll be negative 5 plus minus I root 55 divided by 4. And then divide both numbers by 4 to write it in a plus bi form. We have negative 5 over 4 plus minus square root of 55 over 4 I. And then for your factors, you do x minus the first one, which I wrote as negative 5 over 4 minus I root 55 over 4. And the second factor is negative 5 over 4 plus I root 55 over 4. And then you distribute the subtraction sign, you're going to get x plus 5 over 4 plus I root 55 over 4. And then the other one is x plus 5 over 4 minus I root 55 over 4. Okay. Question?
For the second, like the last part of A for 4, you distributed, you divided by 4 for both of the terms. Do you have to do that?
Are you referring to this step right here?
Yeah, exactly.
Yeah, so you don't well, if they in the homework they ask you to write in a plus bi form. So if they specify that, then you have to divide both numbers by 4. But if not, then technically you can leave it like this. That's okay.
Okay, thank you.
Yeah. Okay, so while you finish copying that, I will close with announcements. One, there's SGI today, per usual, 2:47. You can drop by if you have questions. And secondly, if you didn't leave a comment for quiz 7, which is what the quiz on Monday, please do so on Google Classroom if you want me to grade anything manually. Okay. All right, but yeah, if you have no further questions, you are free to go, and I will see you all tomorrow. All right, take care.
Thank you.
All right, you're welcome.
Have a nice day.
Thanks, you too.